Hello, and welcome to tonight's journey into gentle wonder. I am so glad you are here. Before we begin, let me invite you to settle in. Find a comfortable position, perhaps adjust your pillow, and allow your body to sink a little deeper into wherever you are resting. Tonight we're going to explore one of nature's most peaceful mysteries, the aurora borealis, but not in the way you might expect. We won't be chasing excitement or drama. Instead, we'll let the quiet science of these celestial lights wash over us like a lullaby, each fact a soft step deeper into calm. And just before we begin, if these quiet explorations help you unwind or give you a peaceful way to end your day, consider gently tapping the like button and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. If you find comfort in these nighttime explorations, a gentle like or subscribe helps others discover this space too. One restful mind at a time. But there is no pressure, only invitation. For now, just let your breathing find its natural rhythm. Picture yourself standing on a silent snowfield under an endless sky. The air is crisp and still. Above you, ribbons of soft green light begin to appear. Moving so slowly they seem almost to breathe. Let's begin our journey into their world. The northern lights are born from a conversation between Earth and the sun. High above us, far beyond the weather and the clouds, a delicate exchange takes place every single day. Our sun, that brilliant sphere of burning hydrogen, constantly releases a gentle stream of tiny particles into space. Scientists call this the solar wind, though it moves through perfect silence. These particles, electrons and protons smaller than anything you could see, drift outward from the sun's surface at speeds that seem impossible. Yet they travel for days across the emptiness between worlds. When they finally reach our planet, they encounter something invisible but immensely powerful. Earth's magnetic field, a protective bubble that surrounds us completely. This magnetic shield curves through space in graceful arcs, stretching far beyond the atmosphere, wrapping our world in an embrace we cannot see but that protects us every moment of our lives. Most of the solar particles simply slide around this barrier, deflected gently away, continuing their journey into deeper space. But some, guided by the invisible lines of magnetic force, find pathways that lead them downward toward the poles. There, in the far north and the distant south, these travelers from the sun descend into the uppermost layers of our atmosphere. The air at that altitude is incredibly thin, almost not there at all, yet it contains oxygen and nitrogen, the same elements we breathe, just spread across vast distances. When the sun's particles collide with these atoms, something beautiful happens. The impact gives the atoms a burst of energy, lifting their electrons to higher states, like pushing a swing to make it climb. But atoms cannot hold onto that extra energy for long. Within a fraction of a second, sometimes even faster, they release it again. And when they do, that energy emerges as light. Pure, colorful, silent light that spreads across the darkness. What we see from the ground, those shimmering curtains and glowing arcs, is the combined glow of billions upon billions of these tiny encounters, each one happening independently, yet together creating a tapestry that can stretch across entire continents. The aurora is not one thing moving across the sky, but countless individual moments of light, appearing and fading so quickly that our eyes blend them into continuous motion. It is like watching a gentle rain, each droplet separate, yet together forming something that feels whole and alive. This process happens mostly in silence, far too high for any sound to travel down to us. The particles arrive without fanfare, the atoms glow without noise, and the light simply appears as if the sky itself has learned to whisper in color. There is something deeply peaceful about this. The northern lights are not trying to impress or overwhelm. They simply exist, a natural consequence of physical laws playing out with quiet elegance. Every color you see in the aurora tells a specific story. Green, the most common hue, comes from oxygen atoms glowing at an altitude of about 100 kilometers above the surface. At this height, the air is thin enough that atoms have time to emit their light before colliding with neighbors. The particular shade of green depends on the exact energy of the collision, but it falls into a range that human eyes detect especially well in low light. That is why even faint auroras often appear green to us. Our vision is simply more sensitive to that wavelength when darkness surrounds us. The green can range from pale lime to deep emerald, sometimes appearing almost white when the light is very bright, sometimes seeming to shimmer with an internal glow when it is soft. Red auroras come from oxygen as well, but from much higher up, near the edge of space itself, where the atmosphere becomes so rarefied that atoms can drift for minutes without bumping into anything. At these extreme altitudes, oxygen releases a different wavelength of light, one that appears crimson or deep rose. This red often crowns the top of auroral displays, spreading like a soft blush above the brighter greens below. It moves more slowly, diffusing gently across the sky, and sometimes it is so faint that cameras capture it better than eyes. The red carries a sense of distance and stillness, a reminder of how high these lights truly reach, touching the very boundary where Earth's atmosphere fades into the void. Purple and blue tones emerge when nitrogen molecules join the dance. Nitrogen glows differently than oxygen because it exists as pairs of atoms bonded together, and these molecules vibrate and rotate in complex ways when struck by solar particles. The result is a cooler palette, shades of violet, lavender, and deep blue that often appear along the lower edges of auroral curtains or in fast-moving rays. These colors can be fleeting, appearing for just moments before shifting into other hues, and they give the aurora a sense of depth and layering. When you see purple threading through green, you are witnessing different altitudes and different gases responding together. A vertical painting that extends from about 80 kilometers up to 500 or more. Each color is a fingerprint, a way of identifying which atoms are glowing and where in the atmosphere the light originates. Scientists can look at the spectrum of an aurora and read it like a map, understanding the chemistry and physics of the upper air just by watching the colors shift. But you don't need to be a scientist to appreciate what those colors represent. They're the visible language of the atmosphere, speaking softly about invisible processes, turning abstract physics into something we can simply witness and feel. There is a gentleness to this knowledge, understanding that each shade has a reason, that nothing about the aurora is random, yet it all unfolds with the ease of a breath. The solar wind that powers the aurora is always flowing. Even on quiet days when no auroras appear, the sun continues to release its stream of particles into space. This wind is thinner than the thinnest whisper of air we know, yet it fills the solar system, reaching far beyond the planets, out past the orbit of Pluto, into the space between stars. It carries with it the sun's magnetic field, invisible lines of force that thread through the particle stream like currents in a river. When this wind is calm, it flows around Earth's magnetic shield without much interaction, and the auroras remain faint or absent. But when the sun's surface erupts, when magnetic loops tangle and snap in the star's roiling atmosphere, the wind strengthens into a storm. These solar storms are born from disruptions deep within the sun's outer layers, where magnetic fields constantly shift and realign. Sometimes the tension becomes too great, and a portion of the sun's atmosphere tears free, flinging billions of tons of plasma into space. This eruption, called a coronal mass ejection, travels outward as a shockwave, carrying magnetic energy and charged particles at speeds that can exceed 1,000,000 miles per H-hour. If Earth happens to lie in the path of such an eruption, the impact on our magnetic field can be dramatic. The arriving plasma compresses our magnetosphere, pushing it inward on the sunlit side and stretching it into a long tail on the night side, creating conditions that allow vast amounts of energy to pour into the polar regions. When this happens, the auroras intensify. What might have been a faint glow becomes a brilliant display. Curtains of light surging across the sky, filling the darkness with motion and color. Yet even in these moments of peak activity, the process remains fundamentally gentle. The particles arrive silently. The collisions happen without force we can feel. and the light simply blooms, growing brighter and more complex, but never harsh or violent. There is a rhythm to these storms, a rise and fall that can last for hours or even days, and then a gradual return to quiet as the solar wind settles and the magnetosphere relaxes. The aurora teaches patience in this way, showing that even the grandest displays eventually soften and fade, leaving the sky dark and still once more. Earth's magnetic field is ancient and invisible, yet it shapes our entire existence. Generated deep within the planet's core, where molten iron churns in slow convection, this field extends far into space, creating a protective bubble that shields us from the harshest effects of solar radiation. Without it, the solar wind would gradually strip away our atmosphere, molecule by molecule, leaving the surface exposed to the vacuum of space. This is what happened to Mars long ago when its magnetic field faded. The atmosphere thinned, and the planet became the cold, dry world we see today. Earth's field has endured for billions of years, a silent guardian that we rarely think about, but that makes life possible. The field has a shape, though we cannot see it. Near the equator, the lines of magnetic force run roughly parallel to the ground, looping out into space and curving back toward the poles. At the poles themselves, the field lines point almost straight down, diving into the planet's interior like invisible threads connecting sky and stone. This geometry is what creates the auroral ovals, those rings of light that circle the magnetic poles. Charged particles from the sun follow these field lines, spiraling along them as if sliding down a cosmic rail, and where the lines converge and dip into the atmosphere, the particles collide with air and the aurora appears. The field acts as both a shield and a guide, deflecting most solar energy but channeling a small fraction toward the highest latitudes, where it can safely release into light. The magnetic poles are not the same as the geographic poles. The magnetic North Pole, the point where field lines aim directly downward, currently lies in the Arctic Ocean, hundreds of kilometers from the geographic North Pole. It drifts slowly over time, moving in response to shifts in the molten core below. And this means the auroral oval drifts as well. Maps of where auroras appear most frequently must be updated over decades as the magnetic landscape changes. Right now, the best places to see the northern lights include northern Canada, Alaska, Iceland, Norway, Sweden, and parts of Russia, all regions that sit beneath the auroral oval's typical position. But 1,000 years ago or 1,000 years in the future, those regions might shift slightly as the pole continues its slow migration. There is something quietly humbling about this. The auroras we see tonight appear in nearly the same places they did for people centuries ago, yet the pattern is not fixed forever. The planet beneath us is alive in its own way, constantly adjusting, and the lights respond to those deep, slow changes. This continuity across time gives the aurora a sense of timelessness. The same physics that created glows for ancient observers still operates today, and it will continue long after we're gone, an unbroken thread connecting past, present, and future under the same dark sky. The auroral oval is not a perfect circle. It shifts in size and shape depending on how strongly the solar wind presses against Earth's magnetic field. During quiet periods, the oval contracts toward the poles, becoming smaller and sitting higher in latitude. Observers in places like Tromsø or Fairbanks might see the lights overhead, while those farther south see nothing at all. But when a geomagnetic storm arrives, the oval expands, sometimes dramatically, pushing the auroras toward lower latitudes. During the most intense storms, auroras have been seen as far south as the Caribbean, Florida, and the Mediterranean, places where they appear perhaps once in a lifetime, if that. These rare events are remembered for generations, written about in historical records as nights, when the sky turned red and green, when compasses spun uselessly, and when people wondered if the world itself was changing. The oval expands because the magnetosphere is being compressed and disturbed. As solar wind pressure increases, the day side of the field is pushed inward, and energy builds up in the magnetotail, that long streamer of magnetic field lines extending away from the sun. Eventually, this energy is released in a process called magnetic reconnection, where field lines snap and rearrange, flinging particles back toward Earth. This sudden influx of energy drives the auroral oval outward, lighting up skies that are normally too far from the poles to ever see such displays. The expansion can happen quickly, over the course of an hour, and then slowly retreat as the storm subsides. Watching maps of the auroral oval in real time reveals this breathing motion, a living boundary that pulses with the rhythm of space weather. Even during expansion, the auroras remain most intense near the poles. The farther south you go, the lower the aurora sits on the horizon, often appearing as a faint glow rather than overhead curtains. But for those fortunate enough to witness an aurora at mid-latitudes, the experience is unforgettable. The colors seem out of place, almost unreal, and the motion can be subtle yet mesmerizing, a reminder that the planet's magnetic environment reaches farther than we usually imagine. These rare visits of the aurora to southern skies connect people across latitudes, showing that the same forces shaping polar nights can, under the right conditions, touch nearly anywhere. Auroras follow a rhythm tied to the sun's activity. Our star goes through an 11-year cycle, during which the number of sunspots and solar eruptions rises and falls in a predictable pattern. Near solar maximum, when the sun's surface is most active, geomagnetic storms become more frequent, and auroras appear more often and with greater intensity. During solar minimum, the sun quietens, eruptions become rare, and auroral displays grow sparse and faint. This cycle has been observed for centuries, ever since astronomers began keeping detailed records of sunspots, and it continues to govern the ebb and flow of space weather. Right now, we are climbing toward a solar maximum expected in the next few years, meaning the auroras are becoming more active, offering more opportunities to witness their glow. But even during solar minimum, auroras never disappear completely. The solar wind continues to flow, and Earth's magnetic field continues to channel particles toward the poles. On clear winter nights in the far north, faint arcs of light often appear, quiet and steady, reminding us that the connection between sun and Earth never truly stops. These gentle displays lack the drama of storm-driven auroras, but they carry their own beauty, a soft persistence that mirrors the endless cycle of day and night, summer and winter, ebb and flow. There is comfort in this constancy, in knowing that the lights will return, that the sky above the poles is never truly empty, just waiting for the next breath of solar wind to paint it once again. The height at which auroras occur is a place few humans have ever visited. The glowing curtains appear between about 80 and 500 kilometers above the surface, a region of the atmosphere called the thermosphere. Here, the air is so thin that a single breath's worth of gas would fill a volume the size of a house. Temperatures can soar to over 1,000 degrees Celsius, yet there are so few particles that the heat cannot be felt. There is simply nothing to transfer it. This is where the aurora lives, in a realm that is neither Earth's surface nor outer space, but a transition zone where the two meet and blend. At the lower edge, around 80 kilometers, nitrogen begins to glow with purples and blues. The air here is still dense enough for frequent collisions, so the light appears in quick flashes and narrow beams. Higher up, between 100 and 200 kilometers, oxygen dominates, producing the familiar greens that form the main body of most auroral displays. And higher still, above 300 kilometers, oxygen glows red in the extreme thinness, creating the faint crowns and halos that sometimes cap the brightest storms. The vertical structure of the aurora is a layered painting, each altitude contributing its own color and character, and together forming a column of light that can extend across hundreds of kilometers of vertical space. To an observer on the ground, this structure is invisible. We see only the projection of the light onto the sky, the way we might see a distant mountain range flattened into a silhouette. But instruments aboard satellites can measure the aurora's height directly, using triangulation and imaging from multiple angles. These measurements reveal that what looks like a flat curtain is actually a three-dimensional form, draped along invisible magnetic field lines, extending both horizontally and vertically through the upper atmosphere. Understanding this geometry helps scientists trace the paths that particles take as they descend from space, mapping the invisible architecture of the magnetosphere, one glowing filament at a time. The motion of the aurora is not the motion of air or clouds. Nothing physical is moving across the sky. Instead, what we perceive as motion is a sequence of atoms lighting up and fading, one after another, creating the illusion of flow. It is similar to the way a wave moves across a stadium when people stand and sit in turn. The wave appears to travel, but each person only moves in place. In the aurora, each atom glows briefly and then returns to rest. But the pattern of which atoms are glowing shifts continuously, guided by changes in the flow of incoming particles and the configuration of the magnetic field. This creates ripples, waves, and swirls that can race across the sky at astonishing speeds, even though no individual atom moves more than a tiny distance. When a surge of energy arrives from the magnetosphere, it can trigger a brightening that spreads along an auroral arc in seconds, like a light switch turning on along a wire. The eye follows this brightening and interprets it as motion, as something alive and active. And in a sense, it is alive, not in a biological way, but in the way that any dynamic system responds to input and change. The aurora is constantly adjusting to the conditions around it, responding to shifts in the solar wind, to fluctuations in the magnetic field, to the density of the air it glows within. This responsiveness gives it a quality that feels almost intentional, as if the sky is performing, when in truth it is simply being itself, following the laws that govern light and energy and magnetism. One of the most captivating aspects of the aurora is its silence. Despite the immense energy involved, despite the motion and the brightness, the aurora makes no sound that we can hear. The light appears too high for sound waves to travel back down to the surface, and even if they could, the air is too thin to carry them. This silence adds to the sense of wonder, creating a spectacle that is purely visual, almost dreamlike in its quietness. Standing beneath a bright aurora, you can hear only the wind, the crunch of snow underfoot, perhaps the distant call of an animal. But from the sky itself, nothing. It glows and dances in perfect stillness, a conversation we can see but not hear. There have been reports, scattered and debated, of people claiming to hear faint sounds during intense auroras, crackling, rustling, or hissing noises that seem to accompany the brightest displays. For a long time, scientists dismissed these accounts as imagination or coincidence. But recent research suggests there may be a physical explanation. During strong geomagnetic storms, electric fields can build up near the ground, especially in areas with certain types of vegetation or terrain. When the aurora suddenly brightens overhead, these fields can shift, causing tiny electrical discharges in the air, just above the surface, similar to the static you might hear when touching a doorknob in winter. If this is true, then the sounds people hear are not the aurora itself, but a faint echo of it, a whisper translated through the electric environment at ground level. Whether or not the aurora can be heard, the idea of it having a voice adds another layer to its mystery. It suggests that the lights are not entirely separate from us, that they reach down through the atmosphere in ways we're still discovering. And even if the sounds are rare or subtle, the possibility that the aurora might speak, even in the faintest whisper, makes it feel a little more present, a little more connected to the world we inhabit. For now, though, most encounters with the aurora remain silent, and that silence becomes part of the experience, a space for the mind to fill with its own thoughts, its own sense of awe. The aurora has been witnessed by countless generations of people. Long before science could explain what was happening, humans looked up at the polar skies and saw lights that seemed to come from another world. Different cultures gave the aurora different meanings, weaving it into their myths and stories. In some Norse traditions, the lights were believed to be the reflections of the shields and armor of the Valkyries, warrior maidens who carried fallen heroes to Valhalla. The shimmering motion was the gleam of metal as they rode across the sky, honoring the dead with a celestial procession. In parts of Scandinavia, people thought the lights were caused by schools of herring moving in the ocean, their silver scales catching and reflecting some unseen glow. Among the Sami people of northern Scandinavia, the aurora held both beauty and danger. They called it the light you can hear and treated it with respect. To whistle or wave at the lights was considered unwise, for it might provoke them, and the aurora could descend and harm those who disturbed it. This reverence reflected a deep understanding of the natural world as alive and powerful, deserving of caution as much as admiration. In Inuit cultures across the Arctic, the aurora was often seen as the spirits of ancestors, playing games in the sky or dancing to communicate with the living. The lights were a bridge between worlds, a reminder that those who had passed on were still present, still watching over the people below. In Finland, the aurora is called revontulet, which means foxfires. According to legend, a magical fox ran across the snow, and its tail brushed against the mountains, sending sparks flying up into the sky. These sparks became the aurora, a trail of fire left by a creature moving between earth and heaven. The image is gentle and playful, fitting for a phenomenon that can seem both mischievous and serene. Each culture's interpretation reflects the values and environment of the people who witnessed it. Yet all share a common thread. The aurora is something more than mere light. It is meaningful, powerful, and deeply connected to the human experience of wonder. These stories remind us that the aurora has always been a source of inspiration. Before telescopes and satellites, before we understood atoms and magnetic fields, people still found meaning in the lights. They saw in the aurora a reflection of their own hopes, fears, and beliefs, and they passed those stories down through generations, keeping the mystery alive, even as knowledge grew. Today, we have the science to explain the aurora, but the stories have not lost their value. They connect us to our ancestors, to the long history of humanity looking up at the night sky and asking what it all means. In a way, the old myths and the modern science are both attempts to do the same thing, to understand our place in a vast and beautiful universe. The southern lights, the aurora australis, are the aurora borealis's twin. Every process that creates the northern lights also creates a matching display in the southern hemisphere. The auroral ovals around both magnetic poles are connected by the same field lines, linked by invisible threads that run through the planet's core. When energy surges into the magnetosphere, it often triggers auroras in both hemispheres at once, like two bells ringing in harmony. From space, Earth appears crowned by twin halos of light, one in the north, one in the south, both glowing with the same colors and patterns, separated by the bulk of the planet, but united by the same forces. Yet the southern lights are seen by far fewer people. Antarctica, where the southern auroral oval sits, is a continent of ice with no permanent human population beyond research stations. The few scientists and support staff who spend winters there are among the only witnesses to the aurora australis in its full glory. The Southern Ocean, vast and stormy, offers few opportunities for observation, and the southern tips of inhabited landmasses, places like New Zealand, southern Chile, and Tasmania, only occasionally fall beneath the auroral oval during strong storms. This makes the southern lights a rare sight for most of humanity, a hidden wonder that glows unseen over the ice and waves. Despite their rarity, the southern lights are just as beautiful as their northern counterparts. Photographs taken from Antarctic bases show curtains of green and red draped over glaciers and mountains, reflecting off snow and ice in scenes of almost surreal beauty. Satellites capture the oval from above, revealing that the southern aurora can be even more intense than the northern one, a consequence of slight asymmetries in Earth's magnetic field. The two hemispheres are not perfect mirrors, and the southern magnetic pole is slightly stronger, which can lead to brighter, more concentrated displays. But without many observers, these moments of brilliance often go unrecorded, witnessed only by penguins and seals, or by the instruments aboard orbiting spacecraft. The existence of the aurora australis underscores the global nature of the phenomenon. The auroras are not isolated events, but expressions of planetary-scale processes. The same solar wind that brushes the north also touches the south. The same magnetic field that guides particles to one pole guides them to the other, and the same atmosphere that glows green over Alaska glows green over Antarctica. This symmetry is a reminder that Earth is a whole system, interconnected and balanced, and that the lights we see in one part of the world are part of a much larger story, a conversation between the planet and its star that unfolds simultaneously across both ends of the axis. The best time to see the aurora is during the winter months, when polar nights are longest. In the far north, winter brings extended darkness, with some regions experiencing weeks or even months when the sun never rises above the horizon. This perpetual night creates ideal conditions for aurora viewing, as the sky remains dark for most of the day, giving the lights ample time to appear and develop. The long nights also mean more opportunities. If the aurora is active, it can glow for hours on end, shifting and changing as the night deepens. In summer, by contrast, the sun barely sets, and the sky remains bright enough that all but the strongest auroras are invisible, washed out by the lingering twilight. The equinoxes in March and September are known for producing particularly strong auroras. During these times, Earth's axis tilts neither toward nor away from the sun, and the orientation of the planet's magnetic field, relative to the solar wind, becomes especially favorable for transferring energy into the magnetosphere. This alignment, combined with the increasing darkness as autumn deepens, or the retreating light as spring begins, creates peak conditions for auroral activity. Travelers who plan trips to the Arctic often aim for late February through April, or late August through October, hoping to catch the intersection of dark skies and active space weather. But the aurora is never guaranteed. Even during the best season, in the best location, under a clear sky, the lights may not appear. The solar wind must be active, the magnetosphere must be disturbed, and the auroral oval must expand to cover the observer's location. All of these factors align unpredictably, making every sighting a gift rather than an expectation. This unpredictability adds to the aurora's magic. You cannot command it to appear or schedule it like a show. You can only wait, watch, and hope. And if the lights do come, they feel all the more special for being unearned, a moment of grace offered by the sky. Some of the best auroras occur around local magnetic midnight, the time when your location is on the night side of Earth and aligned with the magnetotail, where magnetic reconnection often releases bursts of energy. This moment doesn't correspond to clock midnight, but rather to the point when the local magnetic meridian is opposite the sun. For many places in the auroral zone, this falls between 10 p.m. and 2 a.m., depending on longitude and time of year. Observers often notice that auroras which have been quiet earlier in the evening suddenly intensify around this time, as if the sky has been waiting for the right moment to awaken. The display can last from minutes to hours, then fade as the energy dissipates and the magnetosphere relaxes. Patience is essential for aurora watching. The lights may appear briefly and then vanish, or they may flicker at the edge of visibility for a long time before blooming into something grand. Experienced watchers know to dress warmly, bring hot drinks, and settle in for a long wait, keeping one eye on the sky and allowing the stillness of the night to become part of the experience. There is a meditative quality to this waiting, a quiet focus that opens the mind to small details, the sound of snow settling, the pattern of stars overhead, the gradual shift of the horizon as Earth rotates. And then, when the aurora appears, it feels like a reward not just for patience, but for presence, for being there, paying attention, ready to receive. Photography has transformed how we see and share the aurora. In the past, People could only describe what they saw, using words to capture the motion and color, often falling short of the reality. Paintings and drawings attempted to preserve the beauty, but they relied on memory and interpretation. With the invention of photography, and especially digital cameras, the aurora became something that could be recorded and shared with precision. Long exposures allow cameras to gather light over seconds or minutes, revealing colors and structures that the human eye, limited by its sensitivity in darkness, might miss entirely. A photograph of the aurora often looks more vibrant than the experience itself, not because the camera lies, but because it sees wavelengths and accumulates light in ways our biology cannot. This has led to a rich visual archive of auroral activity, millions of images captured by both professionals and amateurs. These images inspire people who live far from the auroral zones, offering a glimpse of a phenomenon they may never witness in person. They also serve science, providing data on the shape, color, and timing of auroras that help researchers understand the underlying physics. Time-lapse videos compress hours into seconds, showing the aurora's motion as a fluid dance, revealing patterns that would be hard to perceive in real time. The camera has become a partner in aurora watching, extending our senses and preserving moments that would otherwise fade into memory. Yet there remains something irreplaceable about seeing the aurora with your own eyes. A photograph, no matter how stunning, is still a flat image, a frozen moment. The aurora in person is three-dimensional, immersive, alive in a way that cannot be fully captured. You see it with peripheral vision, catching movement at the edges of your sight. You feel the cold air on your face while the sky glows warm colors above. You sense the depth, the way some curtains seem close while others recede into the distance. And you experience the time, the slow unfolding, the waiting, the surprise when a quiet arc suddenly erupts into motion. These elements combine to create a full experience, one that photographs can suggest but never completely replicate. The aurora connects us to the cosmos in a direct, visceral way. When you watch the lights, you are seeing the sun's influence made visible, the result of events that happened 93 million miles away, translated through the medium of Earth's magnetic field and atmosphere into something you can witness. It is a reminder that we live not in isolation, but within a vast system of interactions, that the light from our star does more than warm the surface. It reaches into the space around our planet, shaping the environment in ways both subtle and spectacular. The aurora makes this relationship tangible, turning abstract concepts like solar wind and magnetic fields into ribbons of color that move across the night. This connection can inspire a sense of belonging. We are part of something much larger than ourselves, linked to the sun, to the planet, to the ancient processes that have shaped both for billions of years. The atoms in our bodies were forged in stars, and the light we see in the aurora comes from those same kinds of processes. Energy released through collisions and transitions that echo the nuclear fusion happening in the sun's core. In a very real way, the aurora is starlight, not the light of distant stars, but the light of our own star, filtered and transformed, painted across the sky in shades that speak of chemistry and physics and the delicate balance that makes our world habitable. There is also a sense of peace that comes from watching the aurora. The lights move slowly, most of the time with a grace that invites stillness. There is no need to do anything but observe, to let the colors wash over you, to breathe in the cold air and feel the quiet. The aurora asks nothing of you. It simply exists, and in that existence, it offers a kind of permission to simply be, to pause, to step outside the rush of daily life and enter a moment of pure experience. For many, this is the true gift of the aurora. Not just its beauty, but the space it creates, a space where wonder and calm can coexist, where the mind can rest while the eyes are filled with light. Scientists study the aurora to understand not only Earth's environment, but also the nature of plasma, the fourth state of matter. Plasma is what the sun is made of, and it fills much of the universe, yet it is something we rarely encounter in everyday life. The aurora is one of the few places where we can observe plasma processes happening naturally and accessibly. By measuring the light emitted, the motion of the curtains, and the magnetic fields involved, researchers gain insights into how plasma behaves under different conditions, knowledge that applies to everything from fusion reactors to the environments around distant stars and black holes. Instruments on the ground and in space work together to study the aurora. All sky cameras capture the visual display, tracking the movement and evolution of the lights over time. Magnetometers measure fluctuations in the magnetic field, detecting the currents that flow through the ionosphere. Radar systems probe the density and temperature of the upper atmosphere, revealing how the aurora heats and disturbs the air. Satellites flying through the auroral zone directly measure the charged particles raining down, recording their energy and composition. Together, these observations build a detailed picture of the aurora as a dynamic, complex system, one that responds to changes in the solar wind and the magnetosphere in ways that are still being unraveled. One of the key discoveries from auroral research is the process of magnetic reconnection, a phenomenon that occurs not only around Earth, but throughout the solar system and beyond. Reconnection happens when magnetic field lines that are pointing in opposite directions come close together and suddenly snap and rearrange, releasing vast amounts of energy in the process. In Earth's magnetotail, this process flings particles back toward the planet, triggering auroras. The same mechanism powers solar flares, heats the sun's corona, and drives jets from black holes. By studying reconnection in the relatively accessible environment of Earth's magnetosphere, scientists can test theories and refine models that apply to these far more extreme and distant phenomena. The aurora also plays a role in the larger conversation about climate and atmospheric science. While the lights themselves occur too high to directly affect weather, the energy they deposit into the upper atmosphere can have indirect effects. Auroral heating can cause the thermosphere to expand, changing the drag experienced by satellites and affecting their orbits. The chemical reactions triggered by auroral particles produce compounds that eventually drift down into the stratosphere, where they interact with ozone. During periods of intense solar activity, these effects can be significant enough to influence atmospheric circulation patterns, though the exact connections are still being researched. Understanding these links helps scientists build more complete models of how Earth's atmosphere responds to external forcing, not just from below but from above. There is a certain poetry to the fact that the aurora, so often seen as a symbol of beauty and mystery, is also a subject of rigorous scientific inquiry. The two perspectives are not in conflict. They enrich each other. Knowing the science behind the aurora doesn't diminish its wonder, it deepens it, adding layers of meaning to the experience. When you watch the lights and know that you are seeing oxygen atoms releasing photons after being struck by electrons from the sun, the spectacle becomes even more astonishing, a direct window into the workings of the universe. And when scientists study the aurora, they do so with a sense of awe, aware that the equations and measurements describe something that is, at its heart, profoundly beautiful. The aurora has inspired countless works of art, music, and literature. Painters have tried to capture its colors and motion, from the soft pastels of Impressionism to the bold strokes of modern abstraction. Composers have written pieces that evoke its shimmering dance, using strings and synthesizers to create sounds that rise and fall like the lights themselves. Poets have described it in verses that reach for metaphors, comparing the aurora to spirits, veils, flames, rivers, breath. Each image an attempt to convey what words alone cannot fully express. The aurora invites creativity because it is inherently evocative, a natural phenomenon that feels almost supernatural, something that exists at the edge of the familiar and the unknown. In literature, the aurora often appears as a symbol of mystery or transformation. Characters who witness it are changed by the experience, seeing the world differently afterward. It can represent hope, beauty, danger, or the presence of the divine, depending on the story. Science fiction writers have imagined auroras on other worlds, glowing in alien colors under foreign skies, while fantasy authors have woven the lights into magic systems, treating them as sources of power or gateways to other realms. The aurora's flexibility as a symbol comes from its real-world qualities. It is both natural and extraordinary, explainable yet still wondrous, grounded in science yet open to interpretation. For many people, seeing the aurora is a bucket list experience, something they dream of for years. Travelers journey to the Arctic, enduring cold and darkness, hoping for a glimpse of the lights. When the aurora finally appears, the reaction is often emotional: tears, laughter, silence, a sense of awe that goes beyond words. There is something about the aurora that touches people deeply, perhaps because it reminds us of the beauty that still exists in the world, untouched by human hands, or perhaps because it connects us to something larger, to the sky, to the cosmos, to the mystery of existence itself. Whatever the reason, the aurora has a power to move people, to create memories that last a lifetime. Even those who never see the aurora in person can feel its pull. Images and videos circulate online, shared widely, and they inspire wonder even from a distance. The aurora has become a symbol of the natural world's majesty, a reminder of what we stand to lose if we don't protect our environment. It is also a symbol of exploration and curiosity, representing the human drive to understand the universe. In this way, the aurora transcends its physical nature, becoming an idea, a beacon that calls to something deep within us, a longing for beauty, for knowledge, for connection. The science of the aurora continues to evolve. New instruments and missions provide ever more detailed observations, revealing structures and processes that were invisible to earlier generations of researchers. Spacecraft fly through the auroral zone, directly sampling the particles and fields. Ground-based networks span the Arctic, coordinating observations across thousands of kilometers to track the large-scale patterns of auroral activity. Computer models simulate the magnetosphere and ionosphere, testing theories and predicting how the aurora will respond to different solar conditions. Each discovery raises new questions, driving the science forward, ensuring that the aurora remains a subject of active research and fascination. One area of ongoing study is the role of electromagnetic waves in accelerating particles. It is not enough for particles to simply arrive from the sun. They must be accelerated to the right energies to produce the aurora's characteristic colors. Waves in the plasma, generated by instabilities in the magnetosphere, can interact with particles, giving them extra speed as they spiral down magnetic field lines. Different types of waves affect different particles in different ways, creating the variety of auroral forms we see. By understanding these wave-particle interactions, scientists can better predict when and where auroras will occur and what they will look like. This knowledge also applies to space weather forecasting, helping to protect satellites and astronauts from harmful radiation. Another mystery is the fine structure of the aurora. High-resolution images show that what looks like a smooth curtain from a distance is actually made up of countless thin filaments, each only a few kilometers wide. These filaments can twist, braid, and pulse on timescales of seconds, creating intricate patterns that hint at complex dynamics in the plasma. Researchers use specialized cameras and radar to study these structures, trying to understand what creates them and how they evolve. The answers could reveal new aspects of plasma physics, with applications far beyond the aurora itself. The aurora also serves as a natural laboratory for studying atmospheric chemistry. The particles that create the lights also break apart molecules, creating reactive species that wouldn't normally exist at those altitudes. These species can recombine in various ways, forming compounds that drift downward and interact with the lower atmosphere. By studying these processes, scientists can better understand the chemical balance of Earth's atmosphere and how it might respond to changes, whether from natural causes like volcanic eruptions or human activities like pollution. The aurora becomes a tool for learning about the planet as a whole, a window into processes that shape the air we breathe. As our understanding of the aurora deepens, so too does our appreciation for its complexity. What seems at first like a simple light show reveals itself to be a multi-layered phenomenon involving the sun, the solar wind, Earth's magnetic field, the upper atmosphere, and countless interactions between particles, fields, and waves. Each layer adds richness to the story, showing that the universe operates on principles that are both elegant and intricate, simple in concept but endlessly detailed in execution. The aurora embodies this duality, beautiful in its simplicity when seen from the ground, astonishingly complex when examined up close. There is a certain comfort in this complexity. It means there is always more to learn, more to discover, more to appreciate. The aurora will never be fully exhausted as a subject of study or a source of wonder. Each generation will see it with fresh eyes, informed by new knowledge, but still capable of being moved by its beauty. The lights will continue to dance long after we're gone, a reminder that the universe is far larger and older than any individual life, yet still accessible to us, still capable of inspiring awe in those who take the time to look up. In many ways, the aurora is a gift. It costs nothing to witness, requires no special equipment beyond clear skies and darkness, and offers a direct experience of the natural world's grandeur. In an age when so much beauty is mediated through screens or commercialized, the aurora remains free and wild, belonging to no one and available to anyone willing to venture into the cold and wait. It is a reminder that some of the most profound experiences in life are also the simplest, requiring only openness, patience, and a willingness to be present. The aurora teaches us about time. It shows us events that happened days ago on the sun, carried across space at incredible speeds, finally manifesting as light above our heads. It connects the past to the present, the distant to the near, in a chain of causation that we can trace and understand. And it reminds us that time in nature operates on many scales, from the milliseconds it takes an atom to emit a photon, to the billions of years it took for the sun and earth to form, to the slow drift of the magnetic poles over centuries. The aurora exists at the intersection of all these timescales, a fleeting event rooted in deep time. It also teaches us about space. The aurora occurs 100 km above the surface, farther than most airplanes fly, yet still well within the bounds of Earth's atmosphere. It is a reminder of how thin that atmosphere is, how fragile the layer of air that sustains life, and how quickly it fades into the vacuum of space. The aurora marks the boundary between our world and the cosmos, a glowing threshold that we can see but not cross, except in vehicles designed to withstand the void. It is a humbling perspective, a visual representation of our planet as a small protected bubble in an immense and hostile environment. Yet the aurora is also a sign of protection. The very processes that create the lights are part of the system that shields us from the harshest aspects of the solar wind. Without the magnetic field, those particles would strike the surface directly, stripping away the atmosphere and making life impossible. The aurora is the visible proof that this shield is working, that the planet is doing its job, deflecting and absorbing energy in ways that keep us safe. In this sense, the lights are not just beautiful, they're reassuring, a nightly reminder that Earth takes care of us in ways we rarely notice. There is also a lesson about interconnection. The aurora is the result of processes that span the solar system, from the nuclear fusion in the sun's core, to the solar wind's journey through space, to the interaction with Earth's magnetic field, to the collisions in the upper atmosphere. Each step depends on the one before it, and the failure of any link would break the chain. The aurora shows us that the universe is not a collection of isolated parts, but a web of relationships, each element influencing and being influenced by others. This perspective can shift how we see ourselves, not as separate from nature, but as embedded within it, part of the same web that produces the lights we admire. Finally, the aurora teaches us about wonder. In a world that often feels mapped and measured, where satellites can photograph every square meter of the planet and search engines can answer any question, the aurora remains a source of genuine surprise. It appears without warning, changes unpredictably, and creates moments that cannot be precisely replicated or controlled. It reminds us that there are still experiences that cannot be fully captured or commodified, that some things must be witnessed firsthand to be truly understood. And it shows us that wonder is not something we outgrow, but a fundamental part of being human, a response to beauty and mystery that connects us across cultures and generations. As we continue our journey into the science and story of the Northern Lights, let yourself relax a little more. Feel the weight of your body sinking into comfort. Notice your breath, slow and steady, like the gentle pulse of the aurora itself. There is no hurry, no need to grasp or hold onto any particular fact. Just let the information flow over you like light, each piece adding to the whole, each moment part of a larger pattern. The aurora is patient, and so can you be. Let's continue. The colors of the aurora shift with the seasons, not because the physics changes, but because the viewing conditions do. In deep winter, when the air is coldest and driest, the atmosphere becomes exceptionally clear. Ice crystals settle out, humidity drops, and the transparency of the air increases dramatically. This means that even faint auroras become visible, their subtle hues reaching the eye with minimal scattering. The greens appear crisper, the reds more defined, and the overall display gains a clarity that summer nights, with their lingering moisture and warmth, cannot match. Winter auroras feel sharper, more present, as if the cold itself has polished the sky into a perfect lens through which the universe can shine. Spring and autumn bring their own character to the lights. During these transitional seasons, the atmosphere is more turbulent, with temperature gradients and shifting weather patterns that can create interesting optical effects. Sometimes thin clouds pass beneath the aurora, and the lights reflect off the cloud tops, creating a layered effect. Glows above and below, with darkness sandwiched between. These moments are rare and fleeting, adding an extra dimension to the experience. The equinox months also tend to produce more intense geomagnetic activity, as mentioned before, which means the auroras themselves are often brighter and more active, compensating for any loss of clarity in the air. The balance of day and night during these periods seems to create a harmony between Earth and Sun, a perfect alignment that allows energy to flow more freely from one to the other. Summer in the high Arctic is a time of midnight sun, when the sky never fully darkens. During this season, auroras still occur. Charged particles still rain down along magnetic field lines, but they remain invisible against the bright twilight. Only the most powerful displays, those driven by major solar storms, can punch through the ambient light to create a faint glow. For this reason, summer is considered the off-season for aurora watching, a time when the phenomenon continues unseen, waiting patiently for the return of darkness. It is a reminder that the aurora doesn't need an audience. It happens regardless, indifferent to whether anyone is there to watch, a performance that continues in daylight, hidden, but not absent, patient and eternal. The rhythms of the aurora are tied to rhythms far older than human civilization. The sun's 11-year cycle has been turning for as long as the sun has existed, billions of years of waxing and waning magnetic activity. The Earth's magnetic field has been guiding particles toward the poles for nearly as long, creating auroras over landscapes that have changed beyond recognition. Dinosaurs may have seen the lights, though they lacked the capacity to wonder at them. Early mammals, emerging into the night, would have witnessed the same green curtains we see today, glowing over forests and plains that no longer exist. The aurora is ancient, a thread of continuity running through deep time, connecting the present to an almost unimaginable past, a living link to epochs when the world looked nothing like it does now. Indigenous peoples of the Arctic have lived with the aurora for thousands of years, developing rich traditions and knowledge passed down through generations. For the Inuit, the lights were often seen as the spirits of animals, particularly seals and whales, dancing in the sky. Some groups believed that the aurora could be influenced by human behavior, that showing respect would keep the lights gentle, while mockery or disrespect might cause them to descend and cause harm. These beliefs reflect a worldview in which natural phenomena are alive and responsive, deserving of the same consideration as any other living being. The aurora was not just a physical event, but a presence, something to be acknowledged and honored, treated with the same respect one would give to an elder or a powerful animal. In parts of Greenland, children were taught not to go outside during bright auroras, especially not alone. The lights were thought to be dangerous, capable of reaching down and snatching away those who wandered too far from safety. Whether this was a literal belief or a cautionary tale to keep children close during the dark winter months is hard to say. But it shows how deeply the aurora was woven into daily life and child rearing practices. The lights were powerful, unpredictable, and commanded respect. They were part of the fabric of existence, as familiar as the ice and the cold, yet never fully understood or tamed. This dual nature, both familiar and mysterious, made the aurora a perfect subject for stories that taught children about respect, caution, and the limits of human understanding. Scandinavian folklore sometimes portrayed the aurora as omens. A particularly bright display might be interpreted as a sign of coming change, either good or ill, depending on the context and the observer. Red auras, being rarer and more dramatic, were often seen as warnings associated with war, bloodshed, or disaster. This association may have been reinforced by historical events, times when bright red auroras coincided with periods of conflict or upheaval, creating a correlation that, while not causal, felt meaningful to those experiencing it. Even today, some people report an eerie feeling when watching intense red auroras, a sense of unease that may be rooted in these old stories, passed down culturally, or perhaps arising from something deeper, a response to unusual natural phenomena that our ancestors learned to heed. The Finnish name for the aurora, revontulet or foxfires, comes from a beautiful legend. A fox, running across the fells of Lapland, swept its tail against the snow, sending up a spray of sparks that rose into the sky and became the lights. In some versions, the fox's fur brushes against the trees or rocks, creating the same effect. The image is enchanting, a blend of the earthly and the celestial, the animal and the cosmic. It reflects a way of seeing the world in which the boundaries between different realms are permeable, where a creature of the land can touch the sky and leave a mark that glows for all to see. This story has been kept alive in Finnish culture, taught to children, referenced in art and music, a gentle reminder of a time when explanations for natural wonders were rooted in the landscape and its inhabitants. In contrast to these mythological interpretations, the scientific understanding of the aurora began relatively recently. For most of human history, the lights were a mystery, observed and wondered at, but not explained. The first steps toward understanding came in the 18th and 19th centuries, as scientists began to study electricity and magnetism. They noticed that auroras seemed to be connected to disturbances in compass needles, suggesting a link to Earth's magnetic field. Observations from different locations showed that auroras appeared most frequently near the poles, hinting at a global pattern. But the mechanism remained unclear until the 20th century, when advances in physics and the advent of space exploration finally provided the missing pieces. The Norwegian scientist Christian Birkeland was one of the pioneers of auroral research. In the early 1900s, he conducted experiments using a magnetized sphere, which he called a terrella, to simulate Earth's magnetic field. He bombarded the sphere with electrons and observed that the particles were guided toward the poles, where they created glowing spots. This demonstrated that the aurora could be explained by charged particles following magnetic field lines, a groundbreaking insight that laid the foundation for modern understanding. Birkeland also proposed that these particles came from the sun, a radical idea at the time, but one that eventually proved correct. His work was decades ahead of its time, and he faced skepticism and criticism from contemporaries who favored other explanations. Only later, with the confirmation of the solar wind's existence, was Birkeland's vision fully validated. The discovery of the solar wind itself came in the mid-20th century. Thanks to observations from early space probes, Scientists detected streams of charged particles flowing outward from the sun, just as Birkeland had predicted. This confirmed that the sun was not just a source of light and heat, but also of a constant wind of plasma that filled the solar system. The realization transformed our understanding of space, showing that it was not empty, but filled with dynamic, flowing matter and energy. The aurora became one of the most visible and accessible manifestations of this solar wind, a ground-level phenomenon that revealed the workings of processes happening millions of kilometers away. This discovery opened up an entire new field of study, heliophysics, dedicated to understanding how the sun influences the space environment throughout the solar system. As satellites began to orbit Earth, they provided new perspectives on the aurora. For the first time, humans could see the auroral ovals from above, glowing rings of light encircling the poles. These images were stunning, showing the global scale and structure of the aurora in ways that ground observations never could. They also allowed scientists to study how the ovals expanded and contracted in response to solar activity, tracking the dynamics of the magnetosphere in real time. The view from space added a new dimension to auroral research, turning a phenomenon that had always been experienced from below into something that could be studied from all angles, inside and out. Satellites revealed that the aurora was not just a local event, but a planetary-scale process, a crown of light that Earth wears constantly, visible or not. Astronauts aboard the International Space Station have a unique relationship with the aurora. They orbit at an altitude of about 400 kilometers, which places them within the upper reaches of the thermosphere, the same region where many auroras occur. This means they sometimes fly directly through the lights, surrounded by the faint glow of excited atoms. The experience is described as surreal, being immersed in a phenomenon that, from the ground, seems untouchable and distant. The aurora appears both above and below, wrapping around the station, and the colors can be intense, brighter than they appear from the surface, because there is no atmosphere in between to scatter the light. For astronauts, the aurora is a reminder of the thin boundary between Earth and space, a living part of the environment they inhabit, proof that they are truly on the edge of two worlds. The space station's orbit takes it over both polar regions, allowing crew members to witness auroras in both hemispheres. They photographed countless displays, capturing images that show the aurora's structure in exquisite detail. These photos are shared with the public, bringing the experience of seeing the lights from space to people around the world. They also serve a scientific purpose, providing data on the height, extent, and brightness of auroras that complement ground-based observations. The combination of perspectives from below, from above, and from within has given scientists a more complete understanding of the aurora than ever before. Each vantage point reveals something new, something that would be invisible from any other position. One of the most beautiful aspects of the aurora, when seen from space, is its curvature. The glowing ovals follow the curve of the Earth, bending over the horizon in a way that reveals the planet's spherical shape. This perspective is humbling, a visual reminder that Earth is a small world suspended in the vastness of space, and that the aurora is a feature of that world, a delicate crown that adorns it. The images evoke a sense of fragility, showing how thin the atmosphere is, how narrow the band in which life exists, and how the aurora marks the edge of that habitable zone, glowing at the boundary where protection meets exposure. From this perspective, Earth looks both beautiful and vulnerable, a precious oasis in the cold emptiness of space. Back on the ground, aurora chasers have developed sophisticated techniques for predicting and finding the lights. They monitor space weather forecasts, which track solar activity and predict when coronal mass ejections or high-speed solar wind streams will reach Earth. They watch real-time data from satellites that measure the strength and direction of the interplanetary magnetic field. Knowing that certain configurations favor auroral activity, they use apps and websites that provide auroral alerts, notifying them when conditions are favorable, and they pay attention to local weather, knowing that clear skies are just as important as geomagnetic activity. Even the best auroral conditions are useless if clouds block the view. The modern aurora chaser is part scientist, part meteorologist and part adventurer, combining knowledge with patience and a willingness to brave the elements. The art of aurora chasing also involves knowing where to go. Light pollution from cities can wash out all but the brightest displays, so chasers seek out dark locations, far from urban glow. They look for places with open horizons, where the sky stretches unobstructed in all directions, allowing them to see the full extent of the display. Bodies of water like lakes or fjords are particularly prized because they provide reflections, doubling the visual impact and adding a sense of depth and symmetry. Snow-covered landscapes also work well, the white surface reflecting the auroral glow and creating an otherworldly atmosphere where the boundary between earth and sky seems to dissolve. The best locations are those where nature remains largely untouched, where darkness is still dark and silence is still silent. Some aurora chasers travel great distances, flying to remote parts of Alaska, northern Canada, Iceland, or Scandinavia, in search of the perfect display. They endure freezing temperatures, sometimes waiting for hours in conditions that would be unbearable without proper preparation. They dress in layers, use hand warmers, bring thermoses of hot drinks, and set up chairs or sleeping bags to stay comfortable during long vigils. The dedication comes from a deep appreciation for the aurora, a willingness to endure discomfort for the chance to witness something extraordinary. And when the lights appear, all the hardship fades, replaced by pure wonder. The cold is forgotten, the fatigue disappears, and all that remains is the experience of being present to something greater than oneself. For others, the aurora is a familiar companion. People who live within the auroral zone see the lights regularly, sometimes dozens of times each winter. For them, the aurora becomes woven into the rhythm of life, a seasonal presence that marks the turning of the year. Children grow up watching the sky, learning to recognize the subtle signs that the lights are beginning. The faint glow on the horizon, the slight greenish tinge to the darkness. They hear stories from elders about particularly memorable displays, nights when the entire sky blazed with color, or when the lights moved so fast they seemed alive. These memories and stories create a cultural connection to the aurora, a shared heritage that binds communities together across generations. In some northern towns, the aurora is celebrated with festivals and events. Locals and visitors gather to watch the lights, sharing food, warmth, and stories while the sky performs overhead. These gatherings create a sense of community, bringing people together in appreciation of a natural wonder that transcends individual experience. The aurora becomes a collective event, something to be witnessed and enjoyed together, reinforcing social bonds and cultural identity. It is a reminder that nature has the power to unite people, offering experiences that are bigger than any one person, that invite sharing and connection. In an increasingly fragmented world, the aurora provides a common ground, a shared experience that cuts across differences and reminds us of our common humanity. The aurora also has economic significance for some regions. Tourism centered on aurora viewing brings visitors from around the world, supporting local economies during the dark winter months. Hotels, tour operators, photographers, and guides all benefit from the influx of aurora chasers. Some places have built entire industries around the lights, offering specialized tours, aurora forecasts, heated viewing domes, and photography workshops. This economic activity provides jobs and income in areas that might otherwise struggle during the off-season, turning a natural phenomenon into a sustainable resource. It is a form of tourism that, when managed responsibly, has relatively low environmental impact, as it requires no infrastructure beyond transportation and accommodation. And the aurora itself is not diminished by being watched. However, this commercialization also raises questions about how we value and experience nature. There is a tension between the aurora as a wild, unpredictable phenomenon and the aurora as a product to be packaged and sold. Some worry that the focus on capturing the perfect photograph or checking an item off a bucket list can detract from the simple act of being present and experiencing the lights without agenda. There is a risk of turning the aurora into a commodity, something to be consumed rather than contemplated, valued for its Instagram potential rather than its intrinsic beauty. These concerns highlight the broader challenge of balancing access and appreciation, of allowing people to experience natural wonders while preserving the sense of wonder itself. It is a conversation worth having about what we lose when we turn everything into content and what we gain when we simply allow ourselves to be present. Yet the aurora resists commodification in important ways. It cannot be scheduled or guaranteed. It appears on its own terms, indifferent to human desires or expectations. This unpredictability preserves a sense of wildness, a reminder that not everything can be controlled or commodified. Even the most expensive tour, the most sophisticated equipment, cannot summon the aurora if the conditions aren't right. In this way, the lights retain their power, their autonomy, remaining a gift of nature rather than a product of human effort. This wildness is part of what makes seeing the aurora so meaningful. It is not something you can simply purchase. It is something you must wait for, hope for, and receive with gratitude when it comes. The aurora teaches patience, humility, and acceptance, lessons that are perhaps more valuable than the spectacle itself. The study of the aurora has also led to practical applications beyond pure science. Understanding how the aurora works requires understanding the magnetosphere, and that knowledge is crucial for protecting technology in space and on the ground. Satellites, power grids, communication systems, and navigation networks are all vulnerable to space weather, and the aurora serves as a visible indicator of when that weather is active. By studying auroral patterns and correlating them with measurements from satellites, scientists can develop models that predict space weather impacts, allowing operators to take protective measures. In this way, the aurora contributes to the safety and reliability of modern infrastructure, a practical benefit that complements its aesthetic and scientific value. The same processes that create beauty also create risk, and understanding both aspects is essential for navigating our technological age. Space weather forecasting has become a sophisticated field, combining observations from multiple sources to predict geomagnetic storms and their effects. Satellites positioned between the Sun and Earth provide early warning when a coronal mass ejection is on the way, giving operators hours or even days to prepare. Ground-based magnetometers detect changes in the magnetic field that signal the arrival of a storm. Auroral cameras and all-sky images track the development of the auroral oval, showing where and how intensely the storm is manifesting. All of this information feeds into models that predict the likelihood and severity of impacts on various systems, from satellites experiencing increased drag to power grids facing induced currents. The models are constantly being refined, incorporating new data and new understanding to improve their accuracy. The forecasts are not perfect. The magnetosphere and ionosphere are complex systems with many variables, and small changes in initial conditions can lead to large differences in outcomes. But they have improved significantly over the years, providing valuable guidance for decision makers. During a major geomagnetic storm, satellite operators might place their spacecraft in safe mode, shutting down non-essential systems to reduce the risk of damage. Power companies might adjust the flow of electricity through their grids to minimize the buildup of induced currents. Airlines might reroute flights away from polar regions, where communication and navigation systems can be disrupted. These actions, informed by space weather forecasts, help mitigate the impacts of storms and protect the technologies on which modern society depends. The aurora, in this context, becomes both a warning and a guide, a visible sign that invisible forces are at work. The connection between the aurora and technology also highlights our vulnerability. We have built a civilization that relies on systems susceptible to disruption by natural processes we don't fully control. The same solar activity that creates beautiful auroras can also cause blackouts, damage satellites, and interfere with communication. This vulnerability is a reminder that, for all our technological sophistication, we remain subject to the forces of nature. The aurora, in this context, is both a marvel and a warning, a beautiful phenomenon that hints at the power of the processes shaping our environment, processes that can help or harm depending on their intensity and our preparedness. It humbles us, reminding us that we are not masters of the universe, but participants in it, subject to its rhythms and its power. Yet there is also something reassuring about this connection. It shows that we're not separate from the natural world, that the same forces that created the conditions for life on Earth continue to influence us in countless ways. The aurora is a bridge between the human and the cosmic, a phenomenon that touches both the ancient rhythms of the planet and the cutting-edge technologies of the modern age. It reminds us that understanding nature is not just an intellectual exercise, but a practical necessity, and that beauty and utility can coexist, each enriching the other. The aurora is proof that science and wonder are not opposites, but partners in the quest to understand our place in the universe. As research continues, new mysteries about the aurora are uncovered. Despite decades of study, there are still aspects of the phenomenon that are not fully understood. For example, scientists are still working to explain the detailed mechanisms that create some of the fine structures seen in auroras. The narrow rays, the beads that appear along arcs, the ripples that move through curtains. These features suggest complex interactions between particles, waves, and fields. Interactions that happen on small scales and fast timescales, making them difficult to observe and model. High-resolution instruments and advanced simulations are helping to unravel these mysteries, revealing the aurora as an even richer and more intricate phenomenon than previously thought. Each answer leads to new questions. Each discovery opens new avenues of investigation, ensuring that the aurora remains a vibrant field of research. Another area of active research is the role of the aurora in the global atmospheric system. Scientists are exploring how auroral energy affects atmospheric circulation, how the chemical products of auroral reactions influence ozone and other trace gases, and how these effects might feed back into climate patterns. While the aurora's direct impact on climate is small compared to factors like greenhouse gases or ocean currents, it is part of the larger picture of how Earth's atmosphere responds to external forcing. Understanding these connections helps build a more complete model of the atmosphere as a dynamic, interconnected system. The aurora, once seen as a purely high-altitude phenomenon, with no connection to the weather below, is now recognized as part of the complex web of interactions that shape our climate. There is also growing interest in comparing Earth's aurora with those of other planets. By studying auroras across the solar system, scientists can test their understanding of how magnetic fields, atmospheres, and solar wind interact under different conditions. Each planet offers a different natural experiment. Jupiter's immense magnetic field and rapid rotation create auroras unlike any seen on Earth, with power outputs that dwarf our own displays. Saturn's aligned field and seasonal changes produce their own unique patterns, with auroras that pulse in rhythm with radio emissions from the planet's interior. Uranus and Neptune, with their tilted offset fields, create auroras that wander across their atmospheres in ways that challenge existing models, defying the symmetry we see on Earth and forcing scientists to rethink their assumptions. Even planets without global magnetic fields like Venus and Mars show auroral-like phenomena in localized regions. On Mars, remnant magnetic fields in the crust create patchy auroras that appear in unexpected places, glowing over ancient magnetized rocks that remember a time when the planet had a global field. On Venus, the interaction between the solar wind and the upper atmosphere creates diffuse glows on the night side, a different kind of aurora that doesn't require a magnetic field at all. Each of these cases teaches something new, expanding the theory of auroras beyond Earth and revealing universal principles that apply throughout the cosmos. The study of planetary auroras shows that Earth's lights are part of a much larger family, variations on a theme that plays out wherever magnetic fields, atmospheres, and stellar winds come together. The search for auroras on exoplanets, planets orbiting other stars, is a frontier that is just beginning to open. If a planet has a magnetic field and orbits a star with an active wind of charged particles, it might have auroras. Detecting those auroras from across interstellar distances is an enormous challenge. but it is not impossible. Radio emissions from auroral processes, similar to those detected from Jupiter, might be detectable with sensitive enough instruments. Observing such emissions would provide evidence of a planet's magnetic field, a key ingredient for habitability, as magnetic fields help protect atmospheres from being stripped away by stellar winds. The aurora, then, could become a tool for finding and characterizing distant worlds, a beacon that signals the presence of the conditions necessary for life. This possibility adds yet another layer of meaning to the aurora. It is not just a beautiful display or a subject of scientific study. It is a potential signature of habitable worlds, a sign that could guide humanity's search for life beyond Earth. The same physics that creates the lights over our polar regions might be creating lights over distant planets, glowing unseen in the darkness of space, waiting to be discovered. The thought is both humbling and inspiring, a reminder that the universe is vast and full of wonders, many of which we have yet to imagine, let alone observe. The aurora connects us not just to our own planet and star, but potentially to other worlds, other systems, other possibilities for life in the universe. Returning to the immediate experience of the aurora, there is something deeply meditative about watching the lights. The slow, graceful motion encourages a state of relaxed attention, a kind of active rest where the mind is engaged but not striving. You can't make the aurora do anything. You can only watch and allow it to unfold. This surrender to the moment, this acceptance of the aurora on its own terms, can be profoundly calming. It is a practice in letting go, in being present without trying to control or predict. In a world that often demands constant action and decision-making, the aurora offers a space where doing nothing is not only acceptable, but the only appropriate response. It teaches us to simply be, to exist in the moment without agenda or expectation. The colors themselves have psychological effects. Green, the most common auroral color, is associated with calm, balance, and renewal. Watching a green aurora can evoke feelings of tranquility, a sense of being connected to nature and to something larger than oneself. The color green is also the color of growing things, of life and vitality, and seeing it glow in the sky creates an unconscious association with these positive qualities. Red, rarer and more dramatic, can evoke awe and even a touch of unease, a reminder of the power behind the beauty. Red is the color of fire, of blood, of intensity, and when it appears in the aurora, it commands attention in a way that green does not. Purple and blue, with their cooler tones, add a sense of mystery and depth, like looking into deep water or into the void of space itself. Together, these colors create an emotional landscape that mirrors the physical one, shifting and changing, inviting the viewer into a dialogue of feeling and perception. The aurora doesn't just stimulate the eyes, it engages the emotions, creating a full-body experience that can be deeply moving. Some people report feeling overwhelmed by the beauty, moved to tears by the sight of the lights dancing overhead. Others feel a sense of peace, a quieting of the mind and a settling of the spirit. Still, others feel energized, inspired, filled with a sense of possibility and wonder. The aurora affects each person differently, but it always creates some kind of response, some shift in mood or perspective. The silence of the aurora amplifies these effects. In the absence of sound, the visual experience becomes more intense, more focused. Every detail stands out: the curve of an arc, the flicker of a ray, the subtle gradations of color. The silence also creates space for internal sounds, the rhythm of your breath, the beating of your heart, the quiet hum of your own thoughts. Watching the aurora becomes an exercise in mindfulness, a practice of being fully present in the moment, aware of both the external spectacle and the internal response. This dual awareness can be deeply centering, grounding the viewer in the here and now, while also opening them to the vastness of the universe. It is a paradox, being both small and connected, insignificant and essential, temporary and eternal. For many, the aurora sparks a sense of spiritual connection, though not necessarily in a religious sense. It is more a feeling of belonging, of being part of a larger whole, of touching something eternal and unchanging, despite the constant flux of daily life. The aurora exists outside of human time and concerns. It was here before us, and will be here after us, a natural process that unfolds with indifference to our presence. Yet when we witness it, we become part of that process, participants in a cosmic event that links the sun, the earth, and the space between. This participation can evoke feelings of humility, gratitude, and peace, a recognition that we are small but not insignificant, temporary but part of something enduring. The aurora reminds us that we are connected to everything, that we are made of the same materials as the stars, governed by the same laws, part of the same universal story. The aurora also invites reflection on impermanence. Each display is unique and fleeting, appearing for a time and then fading, never to be exactly repeated. This impermanence is part of the aurora's beauty. It cannot be possessed or preserved, only experienced in the moment. Photographs and videos can capture an image, but they cannot recreate the feeling of standing beneath the lights. The cold on your skin, the vastness of the sky, the sense of time slowing down. The aurora teaches that some experiences are meant to be lived, not recorded, and that the attempt to capture and hold on to beauty can sometimes diminish it. There is a lesson here about letting go, about appreciating things for what they are without needing to own or control them. The aurora appears, it dances, it fades, and all we can do is be present to it while it lasts. This theme of impermanence extends to the larger cycles of which the aurora is a part. The sun will continue to shine for billions of years, but not forever. Eventually, it will exhaust its fuel, expand into a red giant, and then collapse into a white dwarf, its auroral winds ceasing as it fades. Earth's magnetic field, too, is not permanent. It has reversed many times in the planet's history, and someday it might weaken or disappear entirely, leaving the atmosphere vulnerable and the auroras silent. These timescales are so vast as to be almost meaningless to human minds, yet they remind us that nothing lasts forever, that all things, even the most enduring natural phenomena, are subject to change and eventual end. This awareness of impermanence can be sobering, but it can also be liberating, freeing us from the illusion of permanence and allowing us to appreciate the present more fully. But for now, in this moment, the aurora continues. It glows above the poles, night after night, season after season, year after year. It responds to the sun's activity, brightening and fading, but always returning. It connects the present to the deep past and the distant future, a thread of light running through time. To watch the aurora is to step into that thread, to join the countless people who have watched before, and the countless who will watch after, all linked by the shared experience of witnessing one of nature's most beautiful creations. This continuity is comforting, a reminder that while individual lives are brief, the patterns and processes of nature continue, providing a framework of meaning and beauty that transcends any single existence. There is a quiet joy in this continuity. The aurora doesn't change to suit the times. It doesn't adapt to human culture or technology. It simply is, constant in its variability, eternal in its transience. This steadfastness is comforting in a world that often feels chaotic and unpredictable. The aurora offers a point of stability, a reminder that some things endure, that the natural world continues to operate according to its own rhythms regardless of human activity. This can be a source of peace, a reassurance that there is order and beauty in the universe. Even when our own lives feel disordered or difficult, the aurora is a touchstone, something we can return to, either in person or in memory, when we need to remember what matters, when we need to reconnect with something larger than ourselves. As we near the end of our journey through the science and wonder of the aurora, take a moment to appreciate how far we've come. We've traveled from the surface of the sun to the edge of Earth's atmosphere, from ancient myths to modern satellites, from the experience of a single observer to the perspective of humanity as a whole. We've explored the physics of charged particles and magnetic fields, the chemistry of atmospheric gases, the rhythms of solar cycles and seasonal change. And through it all, we've seen how the aurora connects these disparate elements into a single, coherent phenomenon. A light show that is both simple and infinitely complex, both familiar and endlessly mysterious. The northern lights are many things. They are a physical process, a collision of particles and atoms governed by the laws of physics. They are a cultural symbol, woven into the stories and traditions of the people who live beneath them. They are a scientific puzzle, revealing secrets about the sun, the earth, and the space between. They are a source of beauty, inspiring art, music, and literature across cultures and centuries. They are a tool for understanding space weather, helping protect the technologies on which we depend. And they are an invitation, calling us to step outside, look up, and remember that we are part of a vast and wondrous universe, connected to everything, from the smallest atom to the largest galaxy. Each of these perspectives enriches the others. The science doesn't diminish the beauty, it enhances it, adding layers of meaning and appreciation. The cultural stories don't conflict with the physics, they complement it, showing how humans have always sought to understand and connect with the natural world. The practical applications don't reduce the aurora to mere utility. They demonstrate how knowledge and wonder can work together, each supporting the other. The aurora is all of these things at once, a multifaceted jewel that reflects different truths, depending on how you turn it. All of them valid, all of them part of the whole. To understand the aurora fully is to hold all these perspectives simultaneously, to see it as both particle and wave, both science and art, both utility and beauty. In the end, perhaps the most important thing about the aurora is simply that it exists. In a universe that is often described as cold, empty, and indifferent, the aurora is a reminder of beauty, complexity, and connection. It shows that the cosmos is not just a void, but a place where energy and matter interact in ways that create light, color, motion, and form. It demonstrates that the laws of physics, often presented as abstract and impersonal, can produce results that move the human heart. And it proves that there are still wonders to be found, experiences that can inspire awe and humility, even in an age when so much has been explained and measured. The aurora is a gift, freely given, asking nothing in return except that we take the time to notice, to appreciate, to be present. The aurora invites us to remain curious, to keep asking questions, to never stop looking up. It reminds us that understanding and wonder are not opposites, but partners, each enriching the other. The more we learn about the aurora, the more beautiful it becomes, because we see not just the surface, but the depth, the intricate web of cause and effect that produces each flicker of light. And the more we appreciate its beauty, the more motivated we are to learn, to understand, to protect the conditions that allow it to exist. This cycle of wonder and knowledge, appreciation and understanding, is what makes the aurora such a powerful teacher. It shows us that the pursuit of knowledge doesn't kill wonder, it deepens it, opening new layers of appreciation with each discovery. As you prepare to rest, carry this sense of wonder with you. Let the aurora's gentle light linger in your mind, a soft glow that illuminates the boundary between waking and sleeping. Remember that somewhere, right now, the lights are dancing over the polar ice, painting the darkness with color, continuing their ancient dialogue with the sun. They don't need you to watch, but they're there if you want them, patient and eternal, waiting for the next clear night, the next quiet observer, the next moment of connection. The aurora is happening right now, as you read these words, as you settle into rest, as you prepare for sleep. It is happening above the Arctic and Antarctic, glowing unseen over ice and ocean, a constant presence in the turning of the planet. Feel your breathing slow, deep, and even like the slow pulse of the auroral, oval expanding and contracting. Let your muscles relax, releasing any tension, allowing your body to sink deeper into rest. Picture the aurora in your mind's eye, not as something to grasp or analyze, but simply as a presence, a gentle companion. As you drift toward sleep, the colors fade from green to violet to a soft, formless glow, and then to darkness, a darkness that is not empty but full of possibility, full of peace. The aurora fades, but it doesn't disappear. It simply becomes part of the darkness, woven into the fabric of night, waiting to emerge again when conditions align. The aurora teaches us that endings are also beginnings. Each display fades, but the process continues, ready to begin again when conditions align. Each night ends, but the sun will rise, and the cycle will turn. Each life is temporary, but the universe endures, creating new forms, new lights, new moments of beauty. There is comfort in this cycle, in knowing that while individual moments pass, the larger patterns continue, that the aurora will glow again, that wonder will return, that there is always more to discover, more to appreciate, more to simply be with. The cycle is endless, and we are part of it, carried along in its gentle rhythm, appearing and fading like the lights themselves. Let that comfort settle over you like a soft blanket. Let the knowledge that the aurora is out there, constant in its change, be a lullaby that carries you into sleep. You are safe. You are held. You are part of the same universe that creates the northern lights, made of the same atoms, governed by the same laws, touched by the same starlight. There is nothing you need to do, nowhere you need to go. Just rest, knowing that the world continues to turn, the sky continues to glow, and beauty continues to unfold, whether you are awake to see it or not. The universe doesn't require your attention to continue, it simply is. And in that simple existence, there is peace. The aurora whispers that it is okay to let go, to surrender to the natural rhythms of rest and renewal. Just as the magnetosphere releases its stored energy in bursts of light, you can release the accumulated tensions of the day, allowing them to dissipate into the darkness. Just as atoms return to their ground state after emitting a photon, you can return to your own ground state, a place of peace and equilibrium. The aurora shows us that energy flows in cycles, that activity and rest are both necessary, both natural, both part of the larger pattern. There is no virtue in constant activity, no shame in rest. The universe itself rests, and so can you. In the silence of the night, the aurora glows on. Its light travels from the upper atmosphere to the ground, a journey of 100 kilometers completed in a fraction of a second, bringing color to the darkness. That light can travel even further into the eye of an observer, into the mind, into memory and dream, carrying with it a message of connection, of beauty, of the endless conversation between earth and sky, matter and energy, the temporary and the eternal. The light becomes part of you, absorbed into your memories, shaping the way you see the world. The aurora leaves its mark, subtle but lasting, a reminder that you have witnessed something rare and beautiful. As your consciousness begins to drift, imagine yourself standing once more on that silent snowfield. The aurora stretches above you, a river of light flowing across the stars. You watch without effort, without thought, simply present to the moment. The cold has become comfortable, the darkness welcoming. You are exactly where you need to be, exactly when you need to be there. The aurora dances, and you are part of that dance, a witness, a participant, a small note in a cosmic symphony that has been playing since before time began, and will continue long after you've gone. You are not separate from the aurora. You are part of the same system, the same story, the same unfolding of matter and energy through space and time. The colors shift, becoming softer, more abstract. Green fades to gray, red to shadow. The forms dissolve, the curtains thinning into mist, into nothing. The sky returns to darkness, but a darkness that feels complete, not empty but full, not fearful but safe. In that darkness, you can rest. In that darkness, you can let go. In that darkness, you are home. The darkness is not absence, but presence, not void, but fullness, not end, but beginning. It is the darkness from which all light emerges, the silence from which all sound arises, the stillness from which all motion flows. The aurora bids you good night, not with words, but with a final flicker of light, a gentle pulse that says, I am here, I will be here tomorrow, and the next night, and the night after that. Sleep now, knowing that beauty endures, that wonder waits, that the universe holds you in its vast and gentle embrace. The light fades, and you are left with the echo of it, a warmth in your chest, a softness in your mind, a sense of peace that settles over you like falling snow. The aurora has given you its gift, the gift of presence, of beauty, of connection, and now it releases you to sleep. And so, as the last traces of light fade from your mind's eye, as your breathing slows to the rhythm of sleep, as your thoughts dissolve into the quiet hum of rest, remember this: you are made of stardust, connected to everything, part of the same story that creates the northern lights. You are valuable. You are enough. You are exactly as you should be. Let that truth settle into your bones, into your heart, into the deep places where worry cannot reach. You are not alone. You are not separate. You are part of the vast interconnected web of existence, held and supported by forces you cannot see but that are always present. Sleep now. The aurora will still be there when you wake, waiting patiently for the next clear night, the next moment of connection. But for now, there is only this, only rest, only the gentle dark, only peace. Let yourself sink into it, fully and completely, trusting that you are safe, that you are held, that all is well. There is nothing to fear, nothing to worry about, nothing that cannot wait until tomorrow. For now, there is only the soft darkness, the quiet breath. Allow it, welcome it, surrender to it. The northern lights fade into memory, into dream, into the deep quiet of sleep. And in that quiet you find rest, deep, restful, healing sleep. The kind of sleep that restores and renews, that prepares you for tomorrow, that holds you gently through the night. The aurora's gift to you is this peace, this permission to rest, this reminder that you are part of something beautiful, something vast, something eternal. You carry the light of stars within you, and when you rest, that light renews itself, preparing to shine again when morning comes. Good night. Sleep well. And may the light of the aurora, whether seen or unseen, whether remembered or forgotten, continue to glow softly in your dreams, a gentle companion through the night, a reminder of beauty and wonder, a promise that tomorrow will bring new light, new possibilities, new moments. Rest now, and let the universe care for you as you sleep, holding you in its vast and gentle embrace, protecting you, renewing you, preparing you for whatever comes next. The aurora dances on, above the frozen lands, above the silent seas, above the sleeping world. It dances for no one and for everyone, indifferent and generous, wild and patient, ancient and ever new. It is the sky's lullaby, the planet's nightlight, the sun's love letter written in color across the dark. And as you sink into sleep, you carry that light with you, a small spark of the aurora in your own heart, glowing softly, reminding you that you are connected, you are part of it all, you are home. Sleep now, beneath the aurora's gentle watch. Sleep and dream of light and color, of vast skies and ancient rhythms, of connection and belonging. Sleep and rest, knowing that you are held, you are safe, you are loved by the universe that created you. The aurora glows on, and so do you, a small light in the darkness, beautiful and necessary, temporary and eternal, alone and connected, asleep and forever awake to wonder. Good night.